All right, everybody. Today we are going to take a look at intercept form, and from that form still find all of the stuff that you need to make an accurate graph of a parabola. So intercept form is given to you there. It's y equals a times x minus p times x minus q. Again, the a part is exactly the same, and the reason is that a is the same across all three formats. Standard form, vertex form, and intercept form, and it has the same meaning. So it's called intercept form, and I'm kind of giving you a hint here, but we want to figure out what are the x-intercepts with an equation in this form. Think about how you find x-intercepts. If you can do this on your own, or if you know the answer already, feel free to pause and then come back and confirm that you're right. But the way you find an x-intercept is always by setting y equal to 0 and then find x. Well, if we set y equal to 0, here's what we get. Now, if I'm solving this for x, we actually should know how to do this. This is actually just like solving an equation with factoring. And basically what you do is you would figure out the value of x that would make each parenthesis 0. Basically, you'd set each parenthesis equal to 0 and solve for x. When we do that, we get x equals p and x equals q. So our x-intercepts are p0 and q0. Okay, but notice there's a subtraction sign built in. So assuming there are subtraction signs in those parentheses, your x-intercept will be positive numbers p and q. If it was plus signs, they would both be negative. This is all related to point slope form of graphing. We did something similar to that where we took the opposite of like x and y to create our point that we started with. Also very related to solving with factoring. It's called intercept form because the x-intercepts are given to you. The y-intercept, guys, there's going to be, I can write a few things down there, but in reality, there's not much that we can do to help us here. All we would have to do to find the y-intercept is plug 0 in for both the x's, and then basically just multiply all of this stuff together, and you're going to get y equals some number. And it's basically just going to be that a times negative times whatever's left in both of those parentheses, I guess. So that's actually not super hard to find either, because you just need to do the multiplication. The vertex and axis of symmetry, this is where it gets tough, because right now, vertex form gave us the vertex, gave us the x and y value of the vertex. Standard form, we use negative b over 2a, and I guess that would be one option for figuring out the vertex is multiply it all out, then use negative b over 2a. Boy, that's not particularly useful. However, think about it this way. You know your x-intercepts. What's the relationship between the x value of the vertex and the value of the x-intercepts? You know that p0 and q0 are your x-intercepts. And think about what the relationship is between the x value of your vertex and your x-intercepts. Pause and come back if you think you can kind of handle figuring this out on your own. But the relationship is that because of symmetry, okay, so if my x-intercepts are here and here, the vertex needs to be in the middle, okay? Middle is really the same thing as saying average, right? So p plus q divided by 2. Basically, taking the average of your x-intercepts is going to give you the x value of your vertex, okay? And then again, you have to plug in for x to find the y value. So actually, this is really, I'd say, still overall a little bit easier than working with standard form. Maybe not quite as easy as vertex form, although that had its challenges too. Here, you're given the x-intercepts. The y-intercept is some simple plug in 0 and do some multiplication. And the vertex, you're pretty much given. It's going to be right in the middle of those two x-intercepts. The only annoying part is that the y value is not so easy to find. You do have to plug in for x and then find y to figure out what that value is. So I'm going to do this first one on the back here. I'm going to find all these different pieces. I'll show you guys how to do that. Again, feel free to pause and click ahead as you need to if you're feeling already pretty confident. But I'll show one. I'll have you guys kind of try to do the other, and then we'll go from there. So my x-intercepts, let's figure out those right away since we're in intercept form, are 3, 0, and 5, 0. I'm going to skip ahead to my vertex because I think that's the next natural progression. The vertex is going to have an x value of 4 because 4 is right in the middle of 3 and 5. Again, if you want to see the math, it's 3 plus 5 over 2, which is 8 over 2, which is 4. Now, I do have to plug in 4 to get my y value, so I'm going to do that. I get y equals 4 minus 3 times 4 minus 5. Easier to do the parentheses first. I get 1 times -1, so my y value in this case is -1. So my vertex is all done. I've got my x-intercepts. Now I just need my y-intercept. I'm going to plug in 0 for both my x's. I get 0 minus 3 times 0 minus 5. That's -3 times -5, so my y-intercept is 15. So now I've got all those different pieces that I need to make an effective graph. I'm going to graph my vertex first of 4, -1. I'm going to graph my x-intercepts of 3 and 5. That y equals 15 does not really fit on my graph particularly well, so I'm actually going to figure out another x value. And again, I want to stay pretty close to the vertex. I've already got 3 and 5 figured out, so I think I'm going to plug in the number 6 and see what happens there. I'm going to set x equal to 6 because that seems like it's going to give me something kind of along that line. It's right next to the 2x values that I already have. So when I plug in 6, I get y equals 6 minus 3 times 6 minus 5. That's 3 times 1. So I get a y value of 3. So the point 6, 3 is on my graph. And I can use the axis of symmetry to make another point on the other side. And now I've got a pretty good handle on what my graph looks like. Okay? So that's how I'd go about graphing in vertex form, in intercept form. I don't think it's any more difficult to work with than vertex form, really. I think intercept form works just as well. And I think the benefit here is I actually wrote out a lot of math. A lot of that you probably could have done in your head. So there's one more at the end here. Why don't you guys give this one a try, pause, and then come back? Right, I'm assuming you've paused and then came back, and this is all done. We're just checking here. So my x-intercepts here are going to be 1, 0, and -3, 0. I've got the negative there because there's supposed to be a minus, but I've got a plus. You're basically taking the opposite of those values. Think of what happens when you plug in 1 for x. You would get a 0 in the first parentheses, and so that would make the whole side 0. If you plug in a -3 for both x's, you don't get a 0 in the first parentheses, but you do in the second, and again, that still makes the whole side 0. Again, I'm going to jump to my vertex. The average of 1 and -3 is -1. If I plug that back in for x, I get y equals -2 times -1 minus 1 is -2 times -1 plus 3 is +2, so I get a +8 there. So my vertex is -1, +8. Then I still need my y-intercept. My y-intercept, I'm plugging in 0 for x, so if I do that, I get y equals -2 times 0 minus 1 is -1 times 0 plus 3 is 3. What I end up getting there is +6. So my y-intercept is 0, +6. Looks like I have enough to actually make a nice complete graph here. So my vertex is -1, +8. That's right here. My x-intercepts are 1, 0, and -3, 0. Okay, and if I draw my axis of symmetry on there, yep, it looks like those are symmetric. My y-intercept is 0, 6. And I might as well make a symmetric point on the other side. Connect those all up and try to make it look as U-shaped as possible. I think I did okay there. So again, I think working with intercept form really isn't too bad. Possibly even easier than vertex form when you think about the fact that you get your x-intercepts right off the bat. You get your, and really you could figure out the x value of the vertex even quicker than you could in standard form, I think. So we'll talk about some possible downsides to this formula in class as well, but it's definitely another positive option that you have.